Welcome to Tech Talks. Our DevOps edition today is focused on Splunk APM business workflows. Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customer, and want you to continue in your Splunk journey. Hi, my name is Eric Wallstatter. I'll be hosting this talk along with Jeremy Snyder and Ori Bright. I'm a principal engineer on the APM team, working on distributed tracing and observability. Before that, I was working at a startup called Omnition, acquired by Splunk over a year and a half ago, also working with the focus on distributed tracing and observability.
Hi, I'm Jeremy Snyder. I'm a front-end engineer on the APM team. I've been with Splunk for a little over a year. And before Splunk, I've worked on backends and front ends at companies like Garmin and Amazon.
And I'm Ori Bright. I'm a senior product marketing manager here at Splunk, focused on APM. Before Splunk, I did product marketing and product management at companies like Cisco and VMware. And prior to that, I was a satellite communications engineer in the military. This is our agenda. Today, we're going to talk about a Splunk APM feature called Business Workflows. Our customers love it, and we wanted to share more information about it with you. We'll talk about what problems it is meant to solve and exactly what are business workflows. Then we'll go into a demo to check out how to use business workflows and then how to create them. So let's get started. First, we're going to try to understand what problems are we trying to solve with business workflows. So actually, business workflows is a solution for two similar problems faced by different people in the organization with different roles. The first set of people are the executive owners, the business owner or the engineering executives. And they want to know the overall health of critical application capabilities to make sure that they're meeting their business requirements, important KPIs, or their SLAs. Examples of that would be checking out the response time of an API, or the percentage of successful customers that go through a checkout versus the customers that receive an error if they go through a checkout. And there's a but, and I'll get to it in a minute. The second set of folks who face this problem from a different angle are the SREs, or the developers. And for them, they want to understand if there is an issue with one of those important business KPIs. How do they troubleshoot it quickly? For instance, the SRE might want to know how to filter the service map only by the services that are involved in the checkout process, if the checkout is experiencing issues. And then they want to notify the right team and the right developers to troubleshoot it. Alternatively, the developers, when they create a new release, they might want to know how their new release is going to impact the overall checkout process. So these are very complicated things. And then they have the same caveat, which is that modern applications are based on multiple microservices running on containers or serverless functions. Let's see an example of a modern application. Here in this chart, we can see an application which is composed of multiple microservices that work together to provide the app's functionality. Each service has a blast radius and can impact the entire application. Another thing we can see is that the same service can be involved in multiple functions. So for instance, in this architecture, we can see two main functions or two main branches of the application. But the service on the left, the entry point, is involved in both of these main functions that the application is meant to perform. Legacy APMs just measure the time it takes any transaction to complete end-to-end. But in this case, how do we measure whether a change in one of the downstream services impacted one change or the other? Using entry point doesn't make sense anymore. So that's why we came up with business workflows, which is an easy way to group relevant traces together based either on initiating operation or on any other tag or endpoint or any service downstream. And that way you can enable end-to-end monitoring of KPIs, alert on them, and find root causes and bottlenecks. In the previous example, the application performs two main functions. The upper one is a catalog service or a catalog function, and the lower one performs checkout. And you can see that there are multiple services involved in these two main functions. So as a business owner or as an SRE, my KPIs would be end-to-end transactions for the catalog service and end-to-end transactions for the checkout service. Now, what can you do with business workflows? First, you can monitor and alert on important business KPIs that correspond to different end-to-end transactions. Like we saw in the example just now, we can define one set of transactions to perform the checkout service and and one set of transaction to perform the catalog call. Another thing you can do is accelerate troubleshooting. A single service can be involved in multiple business workflows. So how can you filter out and see which workflow was impacted if there's an issue with the service? Similarly, you can use business workflows to accelerate new feature development. We have customers that in the past, before using Splunk, they used to freeze their code during important shopping seasons because they didn't want to break anything. From their point of view, everything had to be green in order for them to feel comfortable during the shopping season. With business workflows, you can see upfront whether a new service release will impact the end user experience and how it will do so. So if, on the other hand, if you see that something is red, you know whether it impacts the end user or not. So now that we have some more sense of what business workflows are, let's see a demo. Eric, Jeremy, over to you guys.
Thanks, Ori. My name is Eric Wallstatter. I'm a member of the APM team here at Splunk. I'm going to start the demo by walking through an error incident scenario for an example business workflow. Here we see the service map for a typical e-commerce site. There are services for serving ads, making product recommendations, checking out, etc. We're going to focus on the checking out scenario. We have a business workflow set up for the checkout service place order operation. By selecting it, we filter the service map just to those services involved with place order. Because place order workflow is critical to the business, we have the business objective of seeing no errors in that flow. Let's start an investigation by looking at business workflow dashboards. I'll select the Workflows Overview dashboard and the production environment. Now in this overview dashboard, we can compare some key metrics of all of our workflows, including request, duration, and error rate. On the left, we see a ranking of workflows by the highest value. On the right, we see the metrics over time grouped by each workflow. Out of the box, we create these built-in dashboards for you. The dashboards are driven by metrics which can be leveraged to create your own custom dashboards. Metrics all have a lifetime of 13 months, which easily allows for comparing over time. Looking at top workflows by error rate, here we can see that the place order workflow has a high error rate. This is something worth investigating. By clicking on the workflow in the overview page, it will take me to a workflow's details page, which is drilled down on that particular workflow. We can see here a clear error spike at this time. Now we don't want to keep staring at a dashboard to monitor the workflow health, so we can set up a workflow alert detector. Clicking on this bell and selecting New Detector from Chart. In addition to error rate, we could also set up alerts on workflow duration, for example, to make sure workflows are meeting their SLAs. For conditions, we can choose between static threshold and sudden change. I'll set up a static threshold on the error rate with a threshold of 10%. Now here in the preview, we can see what alerts would have been triggered by these detector settings in the past hour. And this red arrow shows that we would have triggered an alert at the error spike. The preview is great because we can see what alerts would be triggered for different settings of the detector. To finish up the alert, I'll proceed to the alert message. We can customize the message in these settings. For recipients, we have many integrations with notification services. I'll just add myself as a recipient. And we can activate the alert rule so that it is useful for the future. Now that we have our alert set up, let's take a look at how we can use troubleshooting to investigate the source of these errors. From any of these charts, I can link back to the service map page to do more troubleshooting by selecting Troubleshoot from this time window. By following the link, my context is preserved so that I can see the same workflow, environment, and time range that I was exploring in the dashboard. Let's take a look at this error sources and workflow chart. This chart automatically detects the most downstream services that are creating errors in our workflow. There's an obvious spike in the currency service. We want to dig deeper into the currency service errors, so let's use Tag Spotlight. I'll select the currency service and navigate to Tag Spotlight. The tag values in these boxes are already filtered for our specific workflow and service, showing the request rate and error rate for each tag value. Looking over the tag boxes, it seems interesting that all the errors are coming from US East 1, shown by this red bar, with no errors coming from US West 1. Now we can filter to US East 1 by clicking on the tag value. And we can look at an error trace from US East 1 by clicking on any time in the error part of the timeline. This brings up example error traces from that time. I'll choose one of them to investigate. Here we see the trace waterfall view for that trace. We see that the front end made a call to checkout service, which made a call to currency service. The currency service is the root cause error for the trace with a status code of 400 shown in dark red. We can open up the span tags for currency service by clicking on that span. By looking over the span tags, we see this suspicious looking exception message, missing required field in request user account status. Perhaps there was a schema incompatibility that was deployed between checkout service and currency service. In a real investigation, we could go back and check to see if there was something wrong with this version of the service that was deployed to US East 1. For the demo, we'll leave that investigation here, having shown the combined value of dashboards and troubleshooting for the workflow error incident scenario. So I'll conclude this part of the demo here and hand it off to Jeremy.
In Eric's demo, he showed how to use a business workflow to monitor and troubleshoot the place order operation in checkout service. as a business owner or a technical service owner, you can configure business workflows to monitor parts of your overall system that you care about, particularly the parts that you provide to other teams or customers. Once you configure business workflows for some part of your system, then for those workflows, you will gain all of the additional monitoring and troubleshooting capability that Eric demonstrated. So what are business workflows exactly, and how do we configure them? Fundamentally, business workflows are tags that are automatically attached to entire traces based on rules that search for some criteria in some part of a trace. Once a workflow tag is added to a trace, then traces can be grouped and filtered based on that tag. As Eric showed, using the workflow filter options in the filter bar, we can filter the service map to just those traces that had the checkout service place order tag. After the workflow filter is applied, we see the travel of entire traces both before and after the condition that defines our workflow in checkout service. As a service owner or operator, this lets me easily see the entire context surrounding requests that reach the part of the service that I'm interested in. I can see all upstream behavior as well as all downstream behavior. And I can see analysis that covers entire traces in my workflow as a whole. I can see the error and request count of the workflow as a whole. I can see how long my workflow takes end to end. I can see which parts of the workflow are contributing most to the latency, which can be useful when trying to improve performance. And I can see which parts of the workflow are originating errors, which helps quickly identify what service is broken when an entire workflow is failing. From the APM landing page, you can see all of your available business workflows live on the top and in the table. So, as a service owner or operator, how can I configure additional business workflows for the parts of the system that I care about? You can reach the business workflow configuration from the landing page. On the business workflow configuration page, each trace is compared to this list of rules starting from the top. The first rule to match assigns the trace to a workflow. At the top, we can see the rule that created the checkout service place order workflow that we just looked at. This rule, for any trace that goes through checkout service, the endpoint will become the workflow. Just to understand this a bit better, let's see what this looks like in a real trace. So to find a trace, we'll start from troubleshooting with the workflow selected. We'll select the service and get an exemplar. And we can see in our exemplar the trace starts in front end and then it reaches checkout service place order. That's the first call into checkout service, so that becomes the workflow. There are other calls to checkout service where it calls itself, but the workflow system picks the first one in the trace. As owners of the checkout service, having this rule is a great way for us to monitor all of the operations that we offer to the rest of the organization, and we can see the context of those operations. So, what other kinds of rules might we want to create? There's a default rule, which is currently disabled, which creates workflows based on the initiating operations of traces. The initiating operation is the first operation in the trace. And we can actually demonstrate how this works by using the rule tester. So if we use that trace we just looked at, we can enable the default rule and disable the higher priority rule. And the rule tester will allow us to test these rules without actually applying them. And we can see that now the workflow has changed. And if we re-enable this rule, we'll see how it takes precedence. You can also create global tag rules. When traces have a global tag that categorizes the trace well, this allows you to turn it into a workflow. In this particular global tag rule, by using the global tag workflow.name, we allow traces to describe their own workflows. This is useful when your system is aware of APM workflows. Your system can run internal rules to determine the workflow when it creates traces. This can help give you extra control and capability over the workflow determination logic. You can also create workflows based on service-specific tags. So let's create a new rule to demonstrate this. We select the service type, select the service, and select the source as tag value. And then we can see this tag is specific to the placed orders service. And this is useful if your service has unique tags that are good for grouping traces. Once we make changes to the rule set, we need to save in order for them to take effect. There will be a short delay before we see the effects. You can watch the new workflows appear live on the landing page. This concludes our tour of APM's new Business Workflows feature. If you have any questions, please reach out and we'd love to help you.